Hi guys, in this lesson we're going to talk about writing and graphing inequalities. Much of this should be review from last year. So an inequality, just to review, you can see here is a mathematical sentence that compares expressions. It contains the symbols right here. So what I want you to do is go ahead and copy this down. So you're copying down the pink here, and you're copying down, the symbols that it contains. Okay, and while you're doing that, I'm just going to start filling this in a bit. Okay, and if you need to pause the video to write anything down, feel free to do that, and then you can restart it. So these four symbols, when they're in math problems, they're pretty obvious, right? You see them there. But if we have a problem that is in words first, and we need to change it into a math problem, then we need to know which words go with which symbols. So you can see the one on the left here is less than. So if you see less than in a problem, that's that symbol right there. And the other words you might see is fewer than. So if you see either of those things, that would be less than. All right, this one here is greater than. So if you see greater than, that goes there. And also more than would go for this symbol. Okay, so if you haven't done so already, go ahead and draw a big box like I have here, and we're going to copy down this chart right here. The next one is less than or equal to. But there's another phrase that you might see with this one, at most. And a final phrase here would be no more than. Okay, and if we look over here on the right, this one is going to be greater than or equal to. You might also see at least. And finally, you might see no less than. Okay, so take a minute, make sure you have this chart copied down. Pause the video if you need to. The ones that give people the most problem are these. And what I always say is you can memorize them, but a better idea would be to think it through. If something is at most, well then that's the highest it can be, right? So if that's the highest it can be, at most right here means that the number you're looking for has to be less than or equal to it, because it can't be more, right? And then over here, if we look at least, if something is at least a certain number, like you have to be at least, I don't know, 10 years old, to go to this camp. 10 years old, at least 10 years old. Well, you can be 11, you can be 12, but you have to be at least 10. That's going to be greater than or equal to, because you can be bigger. You can be greater than. Okay, so make sure you have that copied down. We're going to go ahead and look at an example. So example 1 says a number q plus 5 is greater than or equal to negative 7.9. Write this as an inequality. All right, well, when you see a number q right here, that just means q. So we're going to go ahead and write down q. Then it says plus 5 is greater than or equal to, well, that's going to be this symbol right here, negative 7.9. And that's it. That's how you would do it. Now, if it said to solve it, you would go ahead and solve it also, but this one doesn't say to solve it. You just have to write it. Okay, so all we did was we took the words from the problem, copied them into a mathematical expression right here. Okay, make sure you have that written down as well. What I'd like you to do now is try these two on your own. So I want you to actually copy down the words for the problem, and then do the answer. And then number 2, copy down the words, and then write the answer. So what I want you to do is pause it here, do that. When you're done, hit play, and check your answers versus mine. Okay, so let's take a look. A number x is at most negative 10. All right, a number x, that's an x, at most. Well, if we look back at our chart, or if we just think about it, at most means that x cannot be any greater than negative 10, because the biggest it can be is negative 10. So at most is a less than or equal to negative 10. Number 2, twice a number y is more than 5 halves. All right, well, twice a number y, we would write like this, is more than 5 halves. All right, make sure your answers match mine. And let's move on. Okay, so when we start talking about solutions, go ahead and copy down this pink here at the top. A solution of an inequality is a value that makes the inequality true. Okay, that goes for an equation too. A solution of an equation, right, something with an equals, means that the number makes the equation true. Well, in this case, it makes the inequality true. So go ahead and copy down example number 2. It says, tell whether negative 2 is the solution of each inequality. Okay, so we have to figure out when we take this negative 2 here and we put it in for the letter, we're going to do it here, we're also going to do it here, does the inequality become true? So let's copy down A. We have y minus 5 is less than or equal to negative 6. So what I'm going to do, I'm going to take that negative 2, I'm going to put it in for y. Negative 2 minus 5 is less than or equal to negative 6. So really this is a question mark. Is this true? Well, let's see. Negative 2 minus 5 is negative 7. Negative 7 is less than or equal to negative 6. Well, it only has to be true for one of them. Either negative 7 has to be less than negative 6, or negative 7 has to be equal to negative 6. I know that it's not equal, but is negative 7 less than or is negative 7 less than negative 6? Yeah, so that's a yes. Because when we put in this negative 2, this became true. Let's take a look at B. Negative 5.5 y is less than 14. Okay, so let's put a negative 2 in here. And then remember we have hidden multiplication here, so that's going to give us 11. And then we ask ourselves, is this true? Is 11 less than 14? Yeah. So this is also a solution. Okay, make sure you have all of this copied down, including the problems, not just the answers. All right, so what I would like you to do is try these couple on your own. So you're going to pause the video here, you're going to copy down the problems and do them, and then you're going to press play and check your answers versus mine. Okay, so for these three, we're trying negative 5. Negative 5 here. All right, so I'm going to grab negative 5. I'm going to put it in for x here. Negative 5 plus 12 is 7. So now you ask yourself, is 7 greater than 7? No. 7 is equal to 7. It's not greater than. So that means negative 5 is not a solution of number 3. Okay, let's look at number 4. We'll put a negative 5 in for n. So we're going to do negative 5 divided by 2.5. That's going to give us a negative 2. And then we ask ourselves, is negative 2 greater than or equal to negative 3? Well, it's not greater than. It's not equal to, but it is greater than. Negative 2 is greater than negative 3. So we only need one of these to be true. It's not equal to, but it is greater than. So our answer is yes. Okay, let's look at number 5. I'm putting a negative 5 in for my variable. So 1 minus 2 times negative 5. And then I have to do PEMDAS. So I have to do this multiplication first. 1 minus 2 times negative 5 is negative 10. Well, 1 minus negative 10 is 11. Is 11 less than or equal to 9? Well, it's not less than, and it's not equal to, so that's a no. Okay, so that means negative 5 is not a solution for this problem. All right, so feel free to go back and look at anything you need for those couple. Make sure you have that all copied down. and I will see you in class. Thanks.